What's up everybody? This is 9.2 part 2, and this is dealing with arc length. So a quick review of the stuff in the last video. When we talk about arc measure, that is in degrees. So the entire circle's arc in degrees is 360, right? And so when we draw in radii or diameters, we're sectioning off parts of the circle. And then whenever we have angles whose vertex is at the center, we call that a central angle. And so an arc measure is equal to the measure of the central angle creating the arc. Okay, so if we looked at this diagram right here, this angle measure is the same as this arc measure and vice versa. Okay, remember, minor arcs are less than 180, major arcs are greater than 180, and semicircles are 180 degrees. Okay, so that's arc measure, so found in degrees. The next thing we're talking about is arc length. Okay, and it's important to understand, in order to understand arc length and how we find it, let's think of like ratios or percentages. So if we think of an entire circle, right, and we think that the entire thing around is 360, if we wanted to find the percentage of the arc that's covering the entire circle, we would take the arc measure and divide it by 360. So let's say we had like a 90-degree arc. We would do 90 divided by 360. Well, 90 divided by 360 is 0.25, or that's 25% of the circle is being covered. Okay, and so because we know the total is 360, we can take whatever the arc measure is, divide it by 360, and that gives us the percentage of the circle that arc is covering. Okay, and so the reason why that's important is because the arc length, remember arc length is in inches, feet, compared to the circumference is the exact same ratio, right? So if I think of that highlighted part in blue, that's a certain percentage of the entire circumference. And we know circumference is all the way around, right? And so these two ratios are representing the same percentage of the circle that's being covered. So we can then say that arc measure divided by 360's percentage is going to equal arc length divided by the circumference percentage as well, because again, they're representing the same piece of the circle. And so that's our formula to find arc length. It's arc, and again, important thing to note is that these two things right here are referring to the exact same arc. All right, so it would be arc measure over 360 equals arc length over circumference. And it's important to note that this 360 will never change, and the circumference formula will always be the same. What will change is the radius, depending on what circle we're looking at, right? And so a really easy example here, let's use that 90 again. So let's say that this was a right angle in our diagram. So our ratio would be 90 over 360 equals, and let's for this say our radius is 10. So 90 over 360, so that's representing this percentage of our arc, equals, we're trying to find the arc length over 2 times pi times the radius, or our circumference formula. And so notice that we only have one variable within this equation, so we can now solve for L using our cross multiplying technique. So we're back to ratios where we're fraction equals a fraction, and then we're going to solve for that. Okay, and so that is how you find arc length. Arc measure over 360 equals arc length over circumference, because both of these ratios are equaling the same percentage of the outside part of the circle, which means both of those ratios are then equal. So let's get into a couple examples, and then this video will be done. So it says find the arc length of zy, right? So here's zy that we're trying to find. We can throw an L in if we wanted to. So it's arc measure. So our central angle is 75. So angle arc ZY's measure is 75 over 360. That's our constant. Equals. We don't know what our arc length is. Over 2 times pi times our radius, which is 4. Because remember, this part right here is the circumference of the circle. Okay? And so what's nice is I can do 360 times L, cross multiplying. And in my calculator, I can do 75 times 2 times 3.14 times 4 all at one time. That gets me 1,884. So literally, I just did 75 times 2 times 3.14 times 4 all at once in my calculator. Then I'm going to divide that by 360. And so L equals 5.2. And so that's kind of just how we find arc length. Very straightforward, very simple. Okay, let's do another one. So we're trying to find the arc length of XY. Notice our diameter is 10, so that means that our radius is 5. This is a diameter, so that means that this entire arc is 180. So we can find this central angle, or this arc measure, by just doing 180 minus 130. So I know the arc measure of XY equals 50 degrees, which allows us to now use our formula. Arc measure over 360 equals arc length over circumference, which is 2 pi 5, or you could have done pi times 10, pi times diameter. Up to you, right? Cross multiply, get 360L equals 50 times 2 times 3.14 times 5. I get 1,570. Divide that by 360. Arc length is 4.4 centimeters. And again, I'm just rounding to the tenths place. Let's do 2 more. Okay? So here, they're giving us the arc length and the arc measure, and we are trying to find circumference. Okay, so remember, it's arc measure over 360 equals arc length over circumference. Now, if we're just trying to find circumference, we can plug in a c. If they're asking us to find the radius, we would plug in the equation 2 pi r. Okay, so our arc measure is 120. Our arc length is 16.76, and that would go over circumference. Cross multiply, I get 120c equals 360 times 16.76. That gets me 6,033.6. And then just go ahead and divide that by 120. I get circumference equals 50.28 feet. And again, the difference would be if they asked us to find the radius, I would just substitute in 2 pi r for that right there. Okay? So then I would do 120 times 2, whatever that is, times 3.14. So it'd be that amount times r equals 6,033.6. And then I would just get r by itself. Just like this problem here. So they're asking us to find the radius. All right. We know that arc length DC is 9.77. I can then, because BD is a diameter, I know that this arc measure is 80 degrees, 180 minus 100. So that's going to be 80 over 360 equals arc measure, or excuse me, arc length over 2 pi r. So here's how I'm going to do this. I'm going to do 80 times 2 times 3.14. That gets me 502.4. And r. So I did 80, I cross multiplied this, 80 times 2 times 3.14, then 360 times 9.77. That gets me 3,517.2. And then I'm going to take that amount and divide by 502.4. and that gets me a radius of 7. And so that is how you find arc length. Notice that you do need the arc measure of the arc you're looking at in order to find arc length. All done.